colleagues and my dear students, good morning everybody. Carl Friedrich Gauss referred to mathematics as Queen of Sciences. We call it as Mother of all subjects. I have a definition for model. This definition is from dictionary. A miniature representation of something, a pattern of something to be made, an example for imitation or emulation, a description or analogy used to help visualize something that cannot be directly observed, a system of postulates, data and inferences presented as a mathematical description of an entity or state of affairs. The process of developing a mathematical model is termed as mathematical modeling. It is generally understood as the process of applying mathematics to a real-world problem with a view of understanding the later. Today, this is a precious moment for us because this hall is going to witness the beauty and superiority of mathematics over all the other subjects. I am extremely happy to introduce our chief guest, knowledgeable chief guest, Dr. Rajeshwari Seshadri. She has completed her BSc Education degree in Mathematics, Physics and Chemistry at Mysore University by securing University 5th rank. She has completed her MSc Education degree in Mathematics at Mysore University by securing University 1st rank. She has completed her PhD degree in Applied Mathematics at Indian Institute of Science, Bangalore. I am very much delighted to welcome such a great personality to our institution. Her successes, her achievements, let me read all her achievements. She has so many achievements. She has awarded Senior Research Fellowship of Council of Scientific and Industrial Research. She has awarded Research Associate of Council of Scientific and Industrial Research India during 90-93. Awarded Young Scientist Fellowship from Tamil Nadu State Council for Science and Technology, Chennai. She served as a visiting faculty for the vast program of Wipro to teach engineering mathematics course for the employees of Wipro. Awarded visiting scientist position at Defence Research and Development Laboratory, DRDL, Hyderabad. Awarded consultancy from Jawaharlal Nehru Center for Advanced Scientific Research to work on a DRDO related project during September 2005. She has been awarded Visiting Research Fellowship from Jawaharlal Nehru Center for Advanced Scientific Research to collaborate on a research topic entitled Flow Instabilities with Professor Rodam Narasimha. He is a great Indian aerospace scientist. She was awarded Best Poster Presentation Award at the International Conference on Frontiers in Fluid Mechanics. She acted as resource person to deliver a lecture on the UGC-sponsored refresher course on mathematics organized by Academic Staff College, Bharatdasan University. She was a plenary speaker on the UGC SAF National Conference on Mathematics, Computing and Modeling organized by Gandhigram Rural University during March 2007. Also served as a chairman of a technical session. She was invited resource person in a special seminar organized on account of International Women's Day by Alagappa University. She delivered technical lecture on stability. Conducted by CETFT Division National Aerospace Laboratories, Bangalore on 20th March 2008. She has published 37 international publications. She visited abroad in the country St. Andrews, that is Scotland, UK. She was honorary research assistant for a collaborative research work on fluid dynamics problems. Also, she was in Sweden as visiting fellow for a discussion meeting on numerical solution of differential equation. She visited England, UK for her postdoctoral research assistant on employment. Her research work is on stability analysis on laminar turbulent flows. She has many professional. She has membership on professional bodies. Life member of Ramanujan Mathematical Society, donor member of IAS Alumni Association, life member of Academy of Discrete Mathematics and Applications, life member of Indian Society for Technical Education, life member of Association of Mathematics Teachers of India. Also, she has research and consultancy project, minimal composite theory of 3Ds of boundary layer flows at Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore, aeroacoustic phenomena in hypersonic vehicles at Defence Research and Development Laboratory, DRDL, Hyderabad, developing rapid solver for estimating transition n factors at Queen Mary University of London, UK, low-order theory for compressible boundary layers, postdoctorate at Jawaharlal Nehru Center for Advanced Scientific Research at Bangalore. She has organized more than 20 conferences, workshops as a convener at Sri Visvesvaraya Institute of Technology and Pondicherry University. She has also served so many institutions. She has served Indian Institute of Science Bangalore, Mysore University, and then she has studied Department of Mathematics, Indian Institute of Science Bangalore as a Research Associate, Department of Mathematics, IISc Bangalore as CSIR Research Associate, lecturer in Mathematics in Manonmani Sundarnar University, Research Associate in Jawaharlal Nehru Center for Advanced Scientific Research, Postdoctoral Research and Assistant Professor at Queen Mary Mile End Road, the University of London, UK, Assistant Professor in Mathematics, South Asia International Institute, Hyderabad, Visiting Scientist at Defence Research Laboratory, Hyderabad, Professor in Mathematics and Professor in HOD Department of MCA at Sri Visvesvaraya Institute of Technology, Bangalore. Now she is working as Assistant Professor in Mathematics in Pondicherry University, Pondicherry. So I am very, very happy. A great personality to our college. We welcome you, ma'am. Honored to welcome our dynamic principal. He is a supporter of every activities of our college and he is backbone of our college. I welcome you, sir. I welcome all my colleagues and students for this wonderful day. I welcome you once again.
Good morning to all. Very happy to meet the students of mathematics once again. Before proceeding, I would like to thank the Department of Mathematics for bringing such an eminent person from Pondicherry to our college. So the resume is very long, very impressive, and in fact, I think Madam will be a eternal role model to you. Tamil சொல்றதுனாக்க ஏற்கனவே நம்முடைய கணித துறையில் நிறைய ரோல் மாடல் இருக்கிறாங்க. ஆக்செப்ட் இவங்கெல்லாம் பார்க்குறப்ப அவங்க இன்னொரு பெரிய பிக் ரோல் மாடல். ஐ விஷ் மை ஸ்டூடெண்ட்ஸ் நீங்களும் இந்த மாதிரி மேடம் மாதிரி வரணும். மேடம் ராஜேஸ்வரி சார் அதே மாதிரி வரணும். அவருடைய ரிசல்ட் பார்த்தீங்களா எவ்வளோ பிரபலமாக இருக்கு. native of Tirunelveli town, now settled in Bangalore, pursued her degree courses, degree and UG, PG, PhD in Karnataka, Mysore and IIM Institute of Science Bangalore, working in Bangalore. Then she had postdoctoral research work in UK and then joined as a lecturer in Manonmani Sundarnar University. Then now presently is working in Pondicherry University. She has so many credentials, so many credits to work. நல்லா பார்த்தீங்கன்னா அந்த மாதிரி ஒரு enterprising, eminent scholar நம்ம காலேஜுக்கு வருது. Really we are very fortunate to have. Very fortunate to have such eminent person. And similarly, I would like to say about the Department of Mathematics to our chief guest also. Because our head Department of Mathematics, Dr. Savitri, may not say these words. ஏன்னா அவங்களே போகிறதுக்கிற மாதிரி சொல்ல மாட்டாங்க. I think it's my bounden duty to give some input about this gathering. Chief guest. Madam, really you are going to interact with the creamy layer of Nehru Memorial College. The students of mathematics are creamy layers, very enterprising students, very interesting students, very whether it is an aided course or a self-financing course, whether UG or PG, all the students of mathematics are highly motivated, interesting, intelligent students. So, even the scholars and the research persons who are coming from other places, they also want to talk, they want to interact, only those people who are of such high caliber. So, now coming to subject, the topic is mathematical modeling. You all very know. I am nowhere related to this mathematics subject. Of course, related to the mathematics department, not related to the subject. I do not know much about mathematical modeling, but the introduction given by the head department of mathematics, Dr. Savitri, I understand that a process of developing mathematical model is called mathematical modeling, and in fact this is, I think, being used in all subjects, both science, engineering, medicine, all area. This mathematical modeling is used, and this is used to bring out some what we call results, particularly about the behavior, I think. Only to that extent I know about this mathematical modeling from this presentation given by Dr. V. Savitri. It's because I have no time to refer about these things in books or in internet. So with this brief introduction given by our HOD, I could understand certain things about mathematical modeling. So I need not go about the subject in detail because we have an excellent resource person here. I think this will be a very interesting, very useful session to you. And at this juncture, I take this opportunity to appreciate and thank the Department of Mathematics for organizing such a wonderful session here. Of course, the department has been doing excellently well. You have been organizing so many programs. Even this academic year, within this 62nd working day. Today we have 62nd, 61. So 62nd working day, I think. Around the 61 plus 1. One not one 0 students may confuse. Today, for the students it is 61st working day. For the staff it is 62nd working day. இந்த கணக்கு நல்லா தெரியும் எனக்கு. அதனால இந்த 62 நாட்கள் பார்த்தீங்கன்னாக்கா arranged so many programs. Really, heads of the Department of Mathematics, and I wish the department to organize many more programs of this for the benefit of students. Thank you very much.
Thank you very much for your nice introduction about me. But I would like to introduce myself as a simple person from a village called Kalladekurichi in Tirunelveli district, where I did my 12 years of schooling. Unfortunately, when I finished my 12th, there is no schooling in my native place, otherwise my father wouldn't have allowed outside. So we had to come to Tirunelveli to Saratekar College. That was the only college which had mathematics. So with the NTSC, that time my eldest brother had already gone out for job. So he felt that I should do it in a better college. So I was introduced to an exam called NTSC examination. And now by now many of you might have heard. So I cleared that National Talent Search examination conducted by CBSE, New Delhi, and qualified under that. Then I went to then I went to Mysore to do my BSc yet with a humble idea of becoming a school teacher at the end of that course. BSc 3 year and 1 year BA. Because my father is a teacher in a school. In which school I studied, that's the only school available in Kalladekurichi called Tilagar Vidyalayam, Melilepalli. So even I have lived all my school days in a village, and because of seeing we have to move anyway out of the place and we have to be put in a hostel. So instead of going up to Tirunelveli, I was allowed to go up to Mysore to study there. So having fared well, having got 5th university in the 5th rank in the university, I was allowed to pursue for PG course by my parents. So MSc also I fared well and got the university rank. That is how our career built and it was coming up. So what I want to mention to this audience is that it doesn't matter where you are, what you are studying, it's all with the aptitude, interest and passion what you have with the subject, you will be able to reach any heights. This is what I want to inform you. I am extremely happy to note that 5 years back there was not much popularity for mathematical modeling. Now that many colleges are picking up this idea, and mathematical modeling is a part and parcel of every research activities in mathematics, be it graph theory, be it differential equations, be it algebra and analysis. So now in this talk, I just want to give you the glimpse of what is this mathematical modeling about, how is it useful, and I hope at the end of this lecture, at least I would arise an interest in few of you to take up future studies on this topic. And to make it very easy and understandable, we always go from known to unknown, right? So I will take you through a gradual way of right here school level mathematics, high school level mathematics, higher secondary level mathematics, undergraduate level mathematics, then go to the PG level, MPhil level as well as the PhD level. So you will be able to see some gradation of how the mathematical modeling under this topic this is developed, so that you will be able to realize this after all we know something about it, right? So that is the idea. So we want to talk about mathematical modeling. So as per the tradition, I will be going through these. What is an introduction to mathematical modeling, the need for the modeling, what are the different techniques available in mathematical modeling, certain classification, its importance. Like any other model, this will also have certain limitations. We will be able to list down what are the basic limitations, and I will illustrate this mathematical modeling with certain examples and followed by a conclusion and a summary. Okay, why do we need a mathematical modeling? When you look at it, we have certain standard cases. Based on this, the mathematical modeling, the subject itself was thought of, and what all I am listing here, you see that to find the height of a tower, say Qutub Minar at Delhi, okay, without climbing on the pole or whatever it is, if you want to find the thing, how do you do it? Then comes the finding mass of the earth without using the balance. Find the volume of a body, blood inside the body of a person without bleeding him to death, right? Then estimate the population of India in the year 2020 AD without waiting till then. Estimate the average lifespan of a light bulb manufactured without actually burning a light until it is fused to precisely calculate its lifespan. Estimate the yield of wheat in India from the standing crop without cutting and weighing the whole of it. Okay? Then finding the gun with the best performance, when the performance depends upon 10 parameters, each of them can take 10 different values. Okay, without manufacturing, so if you mathematical law, you will have 10 power 10 parameters, 10 power 10 variables. So without going through all of them, how are you able to get the best performance of a gun? Finding the temperature at the surface of the sun without taking a thermometer there, right? So these are all certain classes taken from the globally from different topics, different areas. For all these kinds and many millions and millions of such models need the proper mathematical understanding to find the solutions of these kinds of things. Next. Okay, so what is this mathematical modeling about? When we say it is a mathematical modeling, basically we claim that it is a simple language. It's a language in terms of mathematics with which we are able to express ourselves, communicate ourselves, and to think logically and manipulate the ideas. Okay, next. So mathematical modeling is about how we use the language of mathematics to express, communicate, and to think about the real world. How we are able to express, communicate, and think about the real world. That is basically our mathematical modeling. Then what is this about? We were going to illustrate with few examples through algebra, geometry, trigonometry, and calculus, which we are already familiar with during our school days and high school days themselves. So a simple mathematical modeling example from the field of algebra, which you have already studied. So look at this very simple example. Suppose the age of a father is 4 times the age of his son. Okay? After 5 years, the age of the father will be only 3 times the age of the son. What are their ages? Have you not come across this in your 6th standard schooling? Okay? How do you do this problem? Our x always comes in handy, right? Let it be x. So what is going to be x here? Father's age. So what will be son's age? 4 times the age of the son is the father. So you have something as x, something as 4x. So what you typically, if you want to say this is the father, this is the son. So you can see it's a pure verbal problem, but psychologically a student of 6th standard feels that there's no number at all. How do we do this as a mathematical problem? That hurdle is always there, right? But if you are able to convert it, translate it into mathematics, oh, idudana, this is what students say, right? Okay, so we have already experienced this. The age of the father is 4 times the age of the son. So it is more suitable to assume the age of son as x, so that the age of the father is 4 times x. We know this, right? Then after 5 years, what do you mean by after 5 years? The days have passed, the days have passed, 5 years have come out. So this will become 4x plus 5. This will become x plus 5. Is that right? After 5 years, what has happened? The father will be only 3 times the age of the son. So the father is going to be only 3 times the age of the son after 5 years. So this is your equation. You can simply solve this algebraic equation, get what is x. So you know what is son's age, you know what is father's age. So this 5-6 line mathematical verbal problem is just a simple mathematical problem. Is that right? So if you are able to translate it into our known cushioned mathematical language, it is very simple for us. So this is how you approach a problem, read it twice, understand what is given, translate it into a mathematical language, and life is simple. Right? So this is one simple example through algebra. Next one. So again, one more example in algebra. 3 consecutive numbers are such that the square of the middle exceeds twice the sum of the other 2 numbers by 4. Find their numbers. Here you have to be little careful with your English also. Where you have to give a pass, you should give correctly. Right? It's like your board mass. You know, what is board mass? What is board mass? All of you are familiar with board mass? Brackets of division, multiplication, addition, subtraction. So which one you have to use first? Whether you use multiplication or the same way, where you have to give a comma. Whether it's a sum of 2 numbers or sum of 2 and the numbers. So that if you read once or twice the English, then you will be familiar with. So here I have a 3 consecutive numbers such that the square of the middle. So immediately we are comfortable if I write x, x minus 1, x plus 1 as a 3 numbers. Even if you put n plus 1, n plus 2, it is not wrong. It's going to be same. But the advantage is when you do the algebraic manipulation with this, it is much more easier. Okay? Because we are talking about the numbers, it's better to write a integer values as this, more meaningful. The square of the middle exceeds twice the sum of the other 2 numbers. Square of the middle exceeds twice the sum of the other numbers. Square of the middle exceeds twice the sum of the other 2 numbers. Twice the sum of the other 2 numbers by 4. Is that right? Exceeds by 4. Twice of the other 2 number by 4, this number exceeds. So this is your equation. Right? So this is a quadratic equation. So you are expected to get 2 values. Again, mathematics, when you model it, it's going to give all possible solutions. But you should be able to physically interpret and check which is right. For example, for the father's age, if you have modeled, if you have got a quadratic equation, the one of the roots happen to be negative, can we take it? We cannot accept a negative age, right? So when you do it mathematically, you have to be careful with the real situations also, what it corresponds to. So parallelly coming back, interpreting it in terms of the real also plays an important role here. This is the quadratic equation. So you are expected to get 2 numbers for n. So which exactly satisfied with our criteria will be your solution. Yes?
No problem. This is n square plus 4. She has given the answer here.
Oh, here I have written wrong.
Yes. N square plus 4 is equal to.
So this is 4n, right?
Yes.
2 into 2n, no? Yeah, 2 into 2n, you are right. And this exceeds by 4. Okay. Oh, good, I have given there.
Yes.
Okay. So the idea is what we are trying to convey is read, though even if it is verbal, don't be panic. I know mathematics, I should be able to do it. With that, bossy attitude, you should approach the problem. You will be able to do it. Don't ever think, will we get it or not? If you start with that pessimistic view, you will not get anything. Be over optimistic, this is what it is. I should be able to crack it, you will be able to do it. Right? Next. Okay, one more through, we'll cross through this one. Algebra we'll skip. Okay, next is through geometry. Okay, we have seen some examples in algebra. We look at geometry. How many times will a wheel of a car rotate in a journey of 88 kilometers if the diameter of the wheel is 56 centimeters? Now you are going to tell me what is the parameters we have to consider here and how do you simplify this? How do you mathematically model this problem now? What is given to you? You have a wheel of a car rotating, right? So this is your wheel. This is where it is starting. What is the information given to you? Something is 88 kilometers. What is 88 kilometers? How many times will a wheel of a car rotate in a journey of 88 kilometers? So from this point, it has to travel to 88 kilometers. So how many times it will rotate is your question. What is given to you? The diameter of the wheel is given to you. Diameter of the wheel is given to you. So D is known implies R is known. If R is known, the 2 pi R is known. The 2 pi R is known, open it. So this is going to be a 2 pi R distance. Right? So 1 perimeter distance will be the distance covered by 1 perimeter distance is 1 rotation, you know. Is that right? So 1 rotation covers 2 pi R distance. How many rotations will cover 88? Sorry? 88 kilometers will be covered by how many rotations? Is that clear? Okay, how many will it be? Do I have the answer? Good, I don't have the answer. Who is going to tell me the answer now quickly? 56 is the diameter. So radius will be 28. So 2 pi radius will be, how much is it? 44 into 4. 176. Is it centimeter or this is centimeter? 176 centimeter. So what will I say? 176 centimeter is 1 rotation. 88 kilometer, how many rotation? 10 chocolates cost 100 rupees, 20 chocolates cost how much? Same logic. Right? But only thing you have to be little careful here. This is in centimeter, this is in kilometer. So into 10 raised to minus 3 centimeter you have to convert, or that you convert it as kilometer. You will know that you should be, you cannot add 2 apples and 3 oranges and say it is a 5 apple or 5 orange, right? So take care of the units appropriately. That's it. Right? So all this what you have studied without explicitly knowing that it is a mathematical modeling problem you are doing. That's all. All through we have been implicitly shown what is the mathematical modeling, how do we translate a verbal problem into mathematical problems, right? So this is the starting point here, mathematical modeling. So all of you know what is the mathematical modeling. Next. Okay, there's one more here in the geometry itself. A student takes a rectangular piece of paper which is 30 centimeter long and 21 centimeter wide. So that's a paper consisting of 30 by 20, right? 30 centimeter by 21 centimeter. Find the area of the biggest circle that can be cut out of the paper. That can be cut out of. What is the biggest circle that can come out of this? For circle means what are the parameters I have to look at? Either the diameter or the radius. So with the available rectangle, can I have a diameter of 30 centimeter here? Not possible. Why? Because the length is only 21 centimeter, the breadth is only 21 centimeter. So the maximum size of the diameter I can have to form my circle is 21. So with 21 as the diameter, whatever is the area, that will be a circle that can be cut out of this piece of rectangle. Is that right? Okay, next. Next is trigonometry. We have seen something in algebra, geometry, then move to trigonometry. Trigonometry, we are 7th standard, am I right? We are introduced to trigonometry during 7th standard or 8th standard if I remember correctly, because my daughter is doing 9th standard. Otherwise I have no way of knowing school mathematics, what is taught in which year. But this because I have been with her 6th, 7th, 8th, I am guiding, I know which subject what this thing is taught. So trigonometry is introduced in 7th standard in the CBSE syllabus. So one example from that is an angle of depression of 2 boards are 60 and 30 degrees. Angle of depression. What is angle of depression? You have a 2 board. Find the distance between the boards Please read the problem completely before we go in for a formulation. One tips to note. Second tip is, wherever possible, try to geometrically represent it either by drawing some figure or some curve or something, some information. So when you are able to translate it as a model in terms of a figure, it is always helpful. Okay? So when reading the angle of depression is 60-30, will be 10 to draw. This is 30, this is 60, something like that. But what is the second sentence telling you? Find the distance between the boards if the boards are on the opposite side of the cliff. So this model is completely wrong. This is your cliff, so this is your cliff, so this is 1, this is 1, this is 30, this is 60. So this is the distance asked. Both the boards are, this is the board 1, this is the board 2. So both the boards are opposite side of the cliff. If I had drawn it this way, it would have been wrong. If you had read only the first sentence and you had modeled it this way, it would have been wrong. So read the problem completely before you start formulation. Is that clear? Okay, then once we know this, using the angles of tan theta is something and all that, I am sure it is cakewalk for you, right? Only thing what is given to you, what is asked is important. So here you will have to do two things. One is with respect to this triangle, one is with respect to this triangle, because it's going to be a 90 degrees, so tan of 30, 1 by root 3 or whatever it is, we can complete the problem. So this is an example through trigonometry. Again another one is find the elevation, that was a depression, this is an elevation. An electric pole is 10 meters high, if its shadow is 10 root 3 meters in length, find the elevation of the sun. Here your distance is given, angle is asked. That is a different reverse problem. The next one is about the calculus. Calculus, it may be the 10th standard or 11th standard. So if a piece of wire is bent, okay, to form a rectangular shape, find the optimal length and width so that its enclosed area is maximum. So here you have given no numbers, okay, only with the parameters. So you have to have a functional form because you are talking about the maximization of an area. What's an area of a rectangle? Length into breadth. Okay, so you are given a length and a breadth. So express length or breadth in terms of your area. So you will get a function of the length and breadth. So if you have to maximize a function, what do you have to do in calculus? What do you have to do? You have to find the derivative, force it to go to 0. Find the double derivative. If it is greater than 0, you call it minimum at that point. If it's less than 0, you call it as maximum. This is what is calculus about, right? So you should be able to use that technique to find the solutions of this problem. Is that clear? Next. Okay, so these are all some simple standard examples, right, only at the school level to show that mathematical modeling is after all not totally new, but the thing what is you are really aware of. Okay, so typically if you want to understand mathematical model, what is mathematical modeling? We have to, whether we like it or not, we need to understand the basic theory behind it. So typically what we are saying is, in any mathematical modeling, you take a real life problem, okay, then you convert it into a mathematical problem like we did here, then find the mathematical solution. Once the solution is arrived, take it back to the interpreting in terms of the real world. As I said, negative age will be meaningless, so you should be able to interpret according to your real life situation. Is that right? So we may, in the process of doing this, we may have to idealize using something, we may have to assume as constant, something we may have to feel that it doesn't change at all. So certain kind of assumptions you may need to make in order to get a suitable solutions. Okay, that you have to take care. Next. So by idealization, what do we mean? Based on the experience and understanding of the situation. Okay? Based on the understanding of the situation, you will convert a real world into a real world model. Then when you want to convert into a mathematical model, you may have to make use of the abstraction of symbolic representation based on your mathematical experience. You may not even know how I should be able to hear. Before when I read the problem, I did not know it's going to model as an algebraic equation or something like a trigonometric equation. We do not know, right? Depending upon the situation, for every problem there's going to be a unique technique. Only when you read it, when you have some mathematical experience, you will be able to say that this falls as this mathematical model and things like that. Okay? Then again, which technique to apply to solve it? When I solve it, If I give this to a third standard, there is n squared. How 2 and 2 values of n can come? I do not know how to solve this, they will say. Right? So now being an undergraduate student, you know how to solve this. But if I give you something on an optimization problem at this level, you may not know. Right? So depending upon the experience of mathematical, what are the different techniques available, you should be able to use it suitably to solve the given mathematical problem. Then you should be able to suitably conclude what was the real problem I took, what was the mathematical solution obtained, how do I interpret it suitably. Right? Next. Okay, so when we say idealization, we say it is at the research level. We say that if I want to study about the motion of the fluid, because my topic of research is mostly on the fluid dynamical problems, so we are interested in studying fluid as a model, then I will assume it as a continuum. I will not be able to pick out some piece of fluid and give it to you. It is all a continuum medium. If it's a solid body, I can give a pinch of that salt to you as a solid. But in the fluid, the assumption is always made as it is continuum when we want to study about the features of the fluid structure. A certain kind of such assumption, so I will neglect that. Of course, that is also made up of molecules, but I don't consider the molecular structure of the system when I study the fluid dynamics. Next. Okay, classification. When I say classification, any mathematical modeling problems will come under three categories. One will be discipline centered, technique centered. When I say discipline centered, it depends upon for the economic subjects, I want to apply the mathematical modeling problem. Or if it is a financial modeling, finance. Or if it's a management, if it is psychology, mathematical biology, chemistry. Depending upon what field, what discipline we want to apply the mathematical modeling, it could be classified as a discipline-oriented mathematical modeling. Okay? Otherwise, I am very good at linear algebra. I want to apply the linear algebraic techniques to solve my problems. I am very good differential equations. I want to use only all those problems when they are modeled mathematically fall as a differential equations. Right? So these are technique centered. Technique means I already know the method of solution of different parts of differential equations. I am aware of it. So I want to only take up all those mathematical modeling problems which fall as a differential equations. So this will be classified as technique centered mathematical modeling. So depending upon the choice, if a professor from banking technology, in fact the other month, last month he came, was asking for some help for mathematics, he came to the department. So here this has fallen as a differential equations. He has approached some other faculty of my department. They said, Rajeshwari, you please go to Rajeshwari if it's a differential equation. If somebody comes to me saying, this is a linear algebra, then I will send it to Mr. X, he is the linear algebra person, go to him. So if it's discipline centered, I know whom to approach so that I should be able to get a solution. In fact, mathematical modeling, it's actually a multidisciplinary one. We don't know where. So an engineer or chartered account or a psychology person or a philosophy person, he may be working on something. Especially when you go to any art or humanities subject, they have lot of case studies, they have lot of data. They will give a piece of paper, everybody will write the information, some numbers are between 0 to n, they will mark. They have this data, they do not know how to analyze. They have to approach us. Only we mathematicians with our known statistical and mathematical techniques, we should help them. This is how you can interpret, this is the possible way of interpretations. Okay? So, being a discipline oriented is much more easier because people will approach us correctly. But if I have to totally take up a model, which it falls into, that is going to be a more difficult one. Is that right? So, a mixture of all this, discipline as well as a technique centered, is going to be what is a situation centered, the third case, wherein a group of engineers, group of economists, group of mathematicians have to work together to find the solution of a certain problem. Is that right? So, this is the three broad categories of classifications of the mathematical modeling. Next. One can spend a lifetime specializing in one specific area of the mathematical modeling alone. So take it only discipline centered, take it only mathematical biology, take it only predator prey model. You can have infinite number of unsolved problems, research oriented problems. You can specialize only in that. So that way each and every field, every topic in that is vast enough. so that you can study for a lifetime. Okay, so what a mathematical modeling should be? What are the different characteristics a model should possess to qualify it as a mathematical model? So typically a model, it should be that's nothing called a good model or bad model. There's nothing called good or bad. How well it replicates my real situation. That is what is more important for me, right? So a model may be good, similar to reality for one purpose and may not. And one model I have framed, so you cannot use it for all the other things. So for depending upon the situation, you may have to slightly change your modeling techniques as well. Okay? As I said, the modeling is neither good nor bad. Whether it fits the given situation, fits the real life situation or not. That is what is most important. Then modeling should be able to force you to think. And in fact, by modeling a given situation, if you have got very many mistakes or if you are not able to get what you want, you have not lost much in terms of learning, but at least you have realized that this is not the good model. Through the mistakes, you are able to correct the things. Like Abdul Kalam said, failure is the stepping stone for success. So you don't get panicked, having spent 1 full month on this modeling, I have got everything wrong. But at least you have learned what should not be done. So that way everything is a process of knowledge. Next. Sticking to one model may prevent your insight, so you should be able to slowly change or refine or modify your models. No feedback models or non-feedback models are improper. That means you should be able to get lot of feedback from your given modeling situation for you to analyze to say whether it is suits the real situation or not. Partial modeling of subsystems are also possible. If your problem itself is very big, try to split it into small sub-models so that each could be solved together and then combinedly you can take the solutions of that. Next. So the present status of mathematical modeling is still gaining popularity, though we have not studied a mathematical modeling as a subject during our undergraduation or post-graduation, but it's implicitly coming in every field that mathematical modeling is part and parcel of every mathematical study. So that is being realized very soon. Lot of seminars are coming up, like how one you have organized here, and a few journals have come up purely in mathematical modeling alone. Several international seminars are being conducted to make the awareness that mathematical modeling is a multidisciplinary subject. So everybody should be aware of this and they should collaborate together to get the best output for a given real life situation. Next. Okay. So, of course, still its importance as a discipline, as a course of study has to be accepted because we don't have a subject called mathematical modeling. If you have something called soft core courses, do you have? Or all are hardcore? What is your type of this thing? I don't know. In your syllabus, your BSc syllabus, you have these 4 subjects are compulsory to study: algebra, analysis, topology, functional. Then some elective subjects you call it. So under the elective subjects, if you could bring in mathematical modeling as one of the subjects, then we can have one course on mathematics. Yes?
Under elective.
You have?
We have, yes.
Mathematics.
Already explained.
Yeah, exactly. So mathematical modeling, it's very interesting to know that you have the course introduced. So that with that you should be able to even take up, I don't know, in your PG level or MP level you have a project. So the project, if you take a real life model and try to model it mathematically, solve it using a suitable technique, and if you are able to interpret the result, it is a very good beginning for your research level studies. Next. Okay, need and importance. Why the mathematical modeling is important? Because it saves a lot of time, it saves a lot of money, it saves a lot of effort in terms of, see for example, this is an airliner, was what you can see here, 777 Boeing. So if you have to, why the nose should be this thick? What is the angle of elevation from this? How should this go? All this, if you have to typically model it in a lab and try to fit it and pass add through it and run and check, it is going to be very tedious, time consuming. But if you are able to simulate all this idea using computer, which keep on changing the numbers, doing a simulation studies through the computer, it is much easier. So all the processes have undergone rigorous research analysis at the background, then only a proper model of the size and the shape of the aircraft or even a car is made. You will see all type of car has a typical model. Why do you say that is the model? It is because of the aerodynamics around how the fluid flows around the car, so that you are able to have a maximum fuel efficiency. The drag force acted on by the air onto the car is minimal by that kind of this thing. You have a shape coming slightly from the front with where you have a bonnet. Okay, so slightly it's increasing up to a certain height. All this profile, the shape and sizes of this is made with a rigorous 4 to 5 years of research analysis. That is why you are able to see the model as almost similar in all types of cars. Same is true for the aeroplane also, because it's flying at a very high altitude. It is facing a heavy pressure and this thing from the air. So how it has to sustain? Only with that research studies it is being made. And my research study, especially in UK, the 3 year of postdoctoral is purely with the aircraft wings. How do we have to have different shapes of wings so that we should be able to, and the wing size, what should be the aspect ratio, what should be the length and breadth, how are you able to get the effect of the machine. So we have done a rigorous analysis. I have crunched more than millions and millions of numbers through computer generation. We have modeled, we have analyzed, and we have done a very good report for the Boeing aircraft. I don't know if you have heard of the company by name Boeing. So we have done project for them. So we have given a very good research analysis based on that. So computational modeling improves the quality of work, reduce the changes that can be made, and they reduce the errors as well as the reducing the reworking. That you will be able to slightly manipulate things. Doing in the computer will be able to save a lot of time and energy and work. Next. Of course, we have certain limitations also, in the sense that anything and everything cannot be modeled so easily. You have a lot of difficulty in terms of the physical, psychological, political. There are a lot of problems. Abdul Kalam's dream was to unite the rivers all over India, right? So though the idea is very nice as a concept, you don't have to have a heavy flood in Cherrapunji and drought in, what is it called? The Rajapalayam, very recently it has come in the paper. It's a heavy drought. People take the water, the pot, and go to 3 kilometers to fetch water. So within India you have such kind of drastic differences between one part to other part. So his dream of uniting or bridging all this thing, it is very nice as an idea, but very, very difficult to incorporate it, mainly because of various political reasons. Tamil Nadu doesn't want to share something with Karnataka, Karnataka doesn't want to share something with Tamil Nadu. So and within the 4 southern states, if this is the case, you can imagine UP and Bihar joining us in all this. So it's almost an impossible dream to be realized, right? So thank God that man is no more now. Okay? So this is the kind of limitations we have, either because the situations are sufficiently complex or the models formed are not mathematically retractable. Okay? Though development of powerful computers has enabled a much larger situations to be mathematically modeled, mathematical modeling themselves may several times pose a great problems to do that. Okay? So mathematical modeling of large-scale systems arise in the study of world models and in global models of environment, oceanography, economic conditions, and population control. So can any one of us predict what will be the price of gold next Monday? Because I want to buy some things. We cannot do that. Right? We cannot predict what is happening to gold, what is happening to the rupee value in terms of dollars. We cannot say. Last week, my friend's son joined in a course in US. Okay, they were supposed to send, they got delayed by 3 days to get the bank loan sanctioned. Just because it was delayed by 1 day, the increase was 40,000 rupees. 40,000 rupees they had to pay extra. $2,000 they had to send it for the tuition fees or whatever it is. Just for the price of 2 or 3 rupees more for a dollar, they have to pay extra 40,000 rupees. So this is the kind of price we have to pay for that. So these kind of predictions, even however well we do it mathematically model, we will not be able to predict the correct ones. So such kind of difficulties are always there. So mathematical modelers from all disciplines are meeting the challenges of the present business. Okay, mathematical language. So you say, I have a real life problem, I want to model it mathematically. but you may not know as a what mathematical equation it fall into. Only we will be able to say it falls any one of these categories, such as it may be a simple algebraic equation like we came across here. It may be a simple transcendental equation like we came out here in terms of sin theta and cos theta. Okay, it may model as a matrix equation. It may model as a system of simultaneous equation and a differential equation. So any one of these kinds of model it will fall into. Of course, that is quite limited. You don't have a very many, infinitely many mathematical model. A standard set of 7 to 8 branches of mathematics. Everything can be, then differential equation can be thought of as a system of simultaneous equations. So you have relations between them. So with a finite set of these 8 of them, we can always bring in any mathematical model into any one of these mathematical equations. Next. Steps for mathematical modeling. How do you model? I don't think it will be required. We'll push it. Skip. So these are steps you have to follow. Anyway, we are going to now, I will show you some typical examples of taking a problem. How do you model it? How do you arrive at a mathematical equation? Of course, not as simple as this. Little BSc level, undergraduate level. Then having got this, how do you solve it mathematically? How do you interpret the results? All that we are going to see for 2 typical situations here. And before that, we started with a set of problems for which mathematical modeling was important. So I want to show you that mathematical models have been developed for all of them. For the set of problems which we have listed. To find the height of the tower, we use the concept of the elevation, angle of elevation, angle of depression technique, by which we will be able to find the height of any given tall building or tall poles. Then to find the mass of the earth, we will rewrite it in terms of the known masses and distances and the way it moves along the elliptic orbit, by which we will be able to calculate it. And to find the volume of the blood present in the body of the person, we have a relation between the glucose level in the body. So take a pinch of blood, measure the glucose content in that, by which we will be able to say what is the total amount of blood present in a person. Then if you want to find out the population in 2020 AD, we extrapolate with the idea already census are being taking place every 5 years. So with the last 20-30 years model, you have a big set of data by which we will be able to arrive at a model and extrapolate the ideas and show that in 2020 approximately this will be like this. Then to estimate the life span of a bulb, we never burn the bulb to death. Instead, we take a sample of the bulb manufactured on a given day, then do a rigorous statistical analysis on that and make sure that you get a number by which you will be able to say that 99% its lifespan is up to this much. So it's a rigorous statistical method and analysis that helps you to find out the lifespan of a given bulb. Then to find out the standing crop's life or how much is the yield of the crop, again you do cutting and weighing the crop representing the plot. So you take a sample, weigh, you will be able to extrapolate and say it. Again for the ballistic gun also you have a theory called the ballistic theory, by which you will be able to arrive at an equation in terms of the mass of the motion of the gas as well as the propellants present there, by which you will be able to find the lifespan of a gun. Surface of the earth, how do you find the temperature? From the property of the light received from its surface. Okay. So now we have a typical example, of course, which may not be this school level one directly you can formulate. You wouldn't know what is the model itself depending upon the problem. So I am going to take a simple example, guide you through what is given. So what model it may fall into. With my passion of what subject I am interested in, you might have guessed what is the modeling. But we are going to go through this and identify what is the mathematical model it falls out as, what is the mathematical equations it results as. Right? So if we take a simple example, a skydiver is falling from rest towards the earth and the parachute opens up instantly at time t is equal to 0 when the skydiver is at a speed of 10 meters per second. What is his speed at any later time when he is in the air? Is the problem clear to you? So a skydiver is at some location here. He is going to fall into the earth here. So he is at some position here. So he starts falling at this place. At this place, his velocity happens to be some 10 meters per second or what is given, I don't know. 10 meters per second. So he is falling from here. So you know that his fall is going to be a projectile, he is going to fall like this. Maybe in a matter of 5 seconds, 6 seconds, 10 seconds, he may fall in any very short time. Okay? Then the question is, what is his speed at any later time when he is in the air? So, if he is at this position, what is his speed? If it is you know that the speed is identically 0 when he falls on the ground. So, I want to find his speed in terms of time. So, u is a speed, u of t, the function of u as a function of t. What is the mathematical model I get? So, when I solve it, I should be able to find at any given instant what will be his speed. That's what we want to find out just from the given information that his starting speed is 10 meters per second. So as he falls down, will his speed increase or decrease? Decrease? Why? Can it not increase and then decrease? That you cannot say whether it increases or decreases unless you know all the parameters associated with this. What is the important parameter which we have to take into account? That person's weight. If he is so hefty a person, what's going to happen? It's going to be fast or slow. If his mass is heavy. Is it directly proportional to his weight or not? Okay, so what do we want to evaluate? The speed with which he travels. You know the direction is always downward towards the air. So we know this thing. So main important thing what we notice, we want important parameters which we need to know is his weight and where he is falling from. Because it may be very heavy air, so that may also be pushing him. You do not know. Underlying surrounding forces are there. If you have a very strong current in a pool or in a river or anything where you are moving, your movement will be very slow because there is a lot of air current within the water itself. So depending upon where he is falling, what is the airflow around him, is it going to push his speed, all that matters. Just because he is given some speed, you will not be able to say decrease it. That is what I said, understand it realistically what the model is. What are all the different parameters you have to take into account before modeling. These are all important. Okay, just like that, because absolutely no other external forces disturbing you, then you can say that ideally this is the situation. But nothing is ideal. Realistic situations are air is going to push you to one side, whether you want to move this side, it will push you to the other end. All that we have to take care. So with respect to these constraints and conditions, how can we model this? What will be the solution? That's what we are interested in. Next. So obviously, when you look at it, you are given some speed related to his mass, he is falling down, so it has to do something with the Newton's laws of motion that we should be able to aware of, right? Force is directly proportional to its acceleration. The constant of proportionality is his mass, you know, F is directly proportional to A. So, it is based on Newton's laws of motion, first thing you have to realize. Then the forces are his weight W and the air resistance. Air resistance is going to be acting negatively. It is going to not allow him to move faster. Is that right? It is going to retard his speed. Then, if you assume that approximately his weight is something, some 75 kg, then you will realize that resultant force with which he will be able to travel is his own weight and the weight due to the gravity. So when you look at these two, you are able to see that the total force is mg minus v square. So you realize that the governing equation which governs his flow, mass into the acceleration is dv by dt, right? Because we have to bring in the v somehow, because the velocity is what we are interested in. So m into dv by dt becomes mg by v square. So this is what is this equation? What is this equation? Differential equations. It's a simple differential equation with a dependent variable v and an independent variable t, right? It's time and velocity. And right hand side is known to you. So this is a simple differential equation and you can do the variable method. So v is a dependent variable, you have a v squared on the right hand side, so it's a non-linear differential equation, right? But you have a standard procedure to solve by the variable separable method. You do bring all the v's and v squared at one side, take mg with the remaining thing there. So if you integrate both the sides, you are going to get v of t as, where is it, v minus k by v plus k is equal to e to the power of pt, where p is some arbitrary constant which you can evaluate using the known value of u is equal to u naught is equal to 10 meters per second. Okay, so what we want to stress here is that it falls as a mathematical model in terms of differential equations because it is dealing with your velocity in terms of time, so relating to Newton's laws of motion. Okay, any doubt here so far? Okay, next. How much time do I have? Should I skip this example? Okay. Yes? 20 minutes, okay? Right. Okay, here is another example just to illustrate to you that when you look at this as a mathematical model, it's a very simple matrix multiplication. All of you have studied matrices, right? Have you been told what is the application of matrices? What is the application of matrices? Why do we need to have a matrix like this? What is the use of matrix multiplications and other things? So this is a simple example to illustrate that mathematical multiplications can lead to very important real solutions for a practical problem. So if you look at this simple problem here, I have a 50 square mile area of land. Okay? In a village, where is it? In 1993, some piece of land of 50 square mile is there. So at the beginning, it's more appropriate if we relate it to our Andhra Pradesh, which is pulled out as Telangana and Andhra Pradesh. So Andhra Pradesh is totally re-establishing now. So in the 50 square mile area, if 30% is allotted for residential use, okay, and 20% is allotted for commercial use, and 50% is allotted for industrial use. 50% in the sense, 50% of square miles, 50 square miles. So 25 square mile is allotted for this.
Don't touch.
Sorry. 25 squares is allotted for this. Among the remaining 25 square feet, 30% for this, 20% for this. Right? Okay. At this situation, you are asked to find the status in this is the status in 1993. Okay. So at the end of 2003, what will be the redistribution of this land? How much will be for residential? How much will be for industrial? How much is it for commercial? That is the question. 1993, the situation is given to you 20, 30 and 50%. At the end of 5 years or at the end of another 5 years, at the end of another 5 years, and as on today, what is the redistribution of the land if you are asked to find out? Okay, so that is done by a simple modeling of a matrix form. Next. So this is a transition probability matrix. How the situation varies over a period is described by this. This number is got from an again rigorous analysis of how these redistributions are being done. So having got this number, this is a probability matrix. So the matrix what you have got to be necessarily less than or equal to 1, the elements, right? So the elements have to be less than or equal to 1. Another condition is each and every row when it is added, it has to give you 1. Okay, this is called the stochastic matrix, which comes in transition probabilities. So you will realize that, next slide, you will realize that using the simple transition probability matrix with the initial condition of 20%, 30%, 50% given, you will be able to easily analyze that at the year 1998, the reach distribution was distributed as 26, 22 and 52. From 30, 20, 50, it is moved to 26, 22, 52. Similarly, at the end of 2003, it has reached 23, 23.2, 53.8. So we again evaluate after 5 years, 2008, if we had evaluated, we would have again got 23.1, 23.1 or something like that. So we will be able to see that after a certain period of maybe 20 years, it is re-established that this is the total distribution. Okay. So to analyze that with a simple idea of matrices, you will be able to realize the nature of the land distribution in a given place. I think I am going to skip this now. This is an elastic membrane problem, again another mathematical model. Stretching of an elastic membrane. I will skip this. Okay, so now I am going to take a very interesting, very simple, practical oriented problem for which some simple mathematical modeling analysis has been done by us, by one of my student, MSc level student. So I just wanted to share with you this idea. So what is the problem about? In 2003, many of you might have heard, of course through your parents, in the paper and media and TV and all, it was very popular. There is a disease called the severe acute respiratory syndrome called SARS, SARS. So this, okay, now there is so much of new, this thing called bird flu, H1N1, HIV, so many. These things are the viruses and these things are spreading out now. One such virus is a SARS virus. In 2003, it broke out in Singapore. Okay, and so many lives of 70, in a short span of 70 days, 206 cases were reported. Okay, and 31 lives were lost. 31 people already died in a matter of 2 months, 70 days. Okay, and 206 people were affected with this virus. So this data is available, how the result broke out in a website. Singapore government has put it up in the website. People have taken it for analysis. So we have also taken that, and what we have done, I am going to show you next. So this table shows you, though it may not be very clear to look at it, the idea is to show that look at each two column as a one entry. So from 0th day, first day, second day, third day, up to the 13th day. On the 0th day, only one person was infected by this virus. On the 13th day, 19 people were infected. On the 15th day, 25 people were infected. On the 28th day, 97 were infected. So if you go like this, last but one column, on the 70th day, 206 people were infected by that virus. On the 38th day, 130 people. 54th day, 193 people, and so on. So I have just concise clubbed all the columns and put it in one page slide. So it may be looking a little cramped. And you can get this data in the paper of Young and Lim in 2008. So what we want to do with this data is, given this set of data, okay, we can use it to model mathematically to find out how this disease has been spread over the 70 days. You know that at the start of the day there were only one person who was infected. So what happened? How did the disease spread so that at the end of 70 days 200 people are already infected? What is the rate of spread of this disease? Can we model this mathematically? That was our idea. So with that idea, how did the outbreak come out of this virus? So to model this disease outbreak, we have done the following thing. As I said, if we are modeling any physically realistic situation, we have to idealize sometimes. Few assumptions we need to make. What is the assumptions I am making here? I assume that in this model, two compartments of populations are susceptible individuals. So what if I want to do the analysis where that infection took place, I am going to close that surrounding. So it is only within this hall where all the people are there, all that society people are there. Okay, though there may be 1,000 people, but only for 200 it has been infected by them. So I close the environment where I am doing the studies to understand the disease of the spread. Okay, so within this group, if I pick up an individual, I will know either he is infected or non-infected, that's all. There is no third category at all. Is that right? The person is either infected or not infected, that's all. So in a closed community of containing capital N number of people, I am doing the analysis. That is the condition I am making. Okay, so what do I say? Susceptible individual means people who are likely to be infected. When I say I, they are already infected individuals. Okay, so under these assumptions, next page. So obviously, like your x, I have to put up some variable here. So I am assuming that my x of t refers to the number of infected people at any given time. Be it 10th day or 15th day or 19th day, I don't know, for a given time. Here time is discrete here in terms of number of days. Okay, at a given time, x of t is going to represent the number of individuals affected. Okay, and n represents the total number of individuals in the community. Total, a capital N represents the total number of individuals in the community. Okay, now I claim that this model can be put it as a differential equation like this. So how do I get this equation when you look at it? Look at the right hand side. My n is a total number of individuals. X is the number of persons affected. So what is my X by N? What is X by N is a ratio. What is this ratio? Tell me. Out of the N number of people, how many were affected? Is that right? So X divided by N represents the total number of people affected out of N people. What is 1 minus X by N tell you? Number of people not affected, because it's a probability. If this many are affected, 1 minus Xn will be not affected. Okay? So this 1 minus X by N is at any given time not affected. Multiplying by an X means with respect to the affected people, X into the number of affected people. Okay? So how? X is the affected people, 1 minus X by N is unaffected people. So from X, how it is going to 1 by N minus X? That is by this constant of proportionality K. So my K refers to your, what is this referring to? This is your spread of the disease parameter. I call it as spreading parameter, or I don't know what it is. Rate of transmission of disease. My K refers to the rate of, this K is a culprit which is going to convert this number to that number to this number. Is that right? So rate of transmission of disease is represented by my parameter K. So what is this totally? What is this telling you? The rate of change of the affecting individual. That is the left hand side. So my dx by dt as a model, the rate of change of the infected people is coming from the number of unaffected people and the number of affected people. This thing is changed by this K. So it's a very simple differential equation model again. As I told you repeatedly, I know only differential equations. So we were able to model it this way. Obviously K has to be 0. So with this value, how do I find out? Already I know at the time of 0, that is on the start of the day, the time is 0, I know only one person was affected. This information I know. So what do we call it as an initial value? Have you studied differential equations? Some second year, third year students are there. So what is an initial value problem different from a typical differential equation problem? Initial value problems gives you the unique solution, exact solution for a given condition. Right? You are given an initial value on which you want to find the solution. So I assume that this is my initial value. So with this initial data, if I solve that differential equation, the solution what I am going to get is a continuous solution, x of t, in terms of that. Solving a simple differential equation, either using mdx plus dy is 0 exact form or a linear equation, I don't know what form you will use. You solve this, you get this is a solution. Here when you look at the right hand side, x naught I know, that is given to me, capital N I know, the number of people, then e to the power of k. K is the constant of proportionality, I do not know. Right, so somehow I have to evaluate what is my k. Okay, so initial conditions means that outbreak started with one infected individual, and here the total number of people is 2206. Next. So this k, I have to evaluate this k. So in order to evaluate this k, I am going to make use of the data already given. When I modeled mathematically, I never used my data at all. I assumed some variable x of t, I assumed n is the total number of people, and I did something. Now, to make use of the data, why do I have to make use of the data? I want to attach my model to the real life situation. This is the data I have got, this is a model I have used. How are they relating to each other? I have to check. So for suitable value of k, I will say that my mathematical model and what is shown as a actual happening, are they matching? That's what I want to check. So obviously I want to see that the error between the given data and the modeling what I am making is minimal. So I find out the total average error. So when I find the error to be minimum, I should be able to get the value of k. So by which if I find the value of k as 16860.1686 is the value, actual value appears when you do the little bit calculations. Next slide. So here is the tabulation. You see that the error, maximum error found in this data is 1.9. Day 0 to 70 represent the day which is given by the data. By the source data available in the web is 1, 2, 3, all the discrete values. At the end of the 4th day, 3% individual. This I have truncated this data. At the end of 70th day, 206, this data is available to me. But my model, mathematical model, my x of t I have already found out. That is giving me these values. So when I compare these two, the error is on the last column. So I want to minimize this error as much as possible so that my mathematical model replicates the real data as good as possible. Next slide. Okay, so the same table, when it is put it more graphically, it is revealing much more good information in the sense that all the blue dots represent my data points. 0th day, this many people, first day, this many people. So if you look at the 30th is the 30 number of days. 30 number of days, when you look at this, there will be around 120 people infected on the 30th day. So the discrete set of data points represented by a blue squares, whereas my beautiful black curves tells me the mathematical model. Because it's a pure analytical solution, an excellent function, an infinitely differentiable function. So you can see a nice curve as a mathematical model. Unfortunately, though being very nice, it doesn't fit my data very well. As you can see here, blue is somewhere on the top, here somewhere on the top. You see that on the first 10 days, it may be suiting very well. In the last 10 days, 60 to 70 also, it may be my model and the given data are fitting well. But in between, it doesn't work very well at all. So, we are still not satisfied, but at least I know that we are on the track. Modeling as a mathematical differential equation is okay, but I have to refine the model, this tells me. So, we go a bit further to check whether I can refine the model. So, in order to refine it, next, I check. So, between T15 and 50, it doesn't replicate only the analysis of that. So, to improve the result, what I am saying is, my x of t varies in terms of, so earlier what we took, x by n is the ratio of affected people. So now I am taking, it is x by n power p rather than just an x by n. So if I introduce a logistic character p, whether it is improved my model, I want to see. So this is the logistic improvement in terms of the differential equation knowledge. So if I do that with that same typical analysis, if I try to do this next, you realize that the red is the second curve with it. So black and red are almost embedded one on the top of other, so it is not shown here. But this is a modified logistic model. In this modified model, what you see, that has gone out of place. That was much closer earlier, but that has gone out. But at least it is much, the gap between this and this is reduced now. Right? So you are able to see that we are still approaching. So further refinement, if I do, you see that you are able to fit this more closely with an error of less than 10 raised to minus 2. I am able to approach the real life. So I claim with this new model, you see that red curve and blue dot points are matching almost similarly. So when you do a little bit of refinement with the model simulation, you are able to see that you are able to replicate your data. So what is the advantage of this model? If we are able to, I will say, if nothing has been done to prevent, then I will say on the 100th day, you would have lost, the disease would have increased to 250 people. At the end of 150 days, it would have gone to 375 people. I will be able to extrapolate the data and say that this is going to be a scenario, better act fast. Is that right? So the advantage of mathematical modeling is even futuristic, this thing we will be able to predict with this mathematical model. This is the idea. So how do we do that? We obviously need the model with respect to, so to check, to validate this, what we do is, we only take first 30 days data. First 30 days alone we will take, we do the typical working out and we see that on the 40th day what we got, what was in the already in the data were exactly coincide. Take only the first 40 days data, on the 50th day what would have happened? My model will tell you the exact number how many were affected here. That is how you justify that the modeling what you have done is exactly suiting with the real data. Is that right? So this is one simple illustration that even a physical problem, a real life problem, how we are able to mathematically model it and give a realistic meaning to the situations and the suitable solutions for this problem. Okay? So this is one example. Several conclusions, we may not need all that. Next. Okay, so if we have time, another 10 minutes, one more interesting problem. Again, how we model it mathematically, though it may never fall in the mathematical category. A biologist may not be able to do it at all, but we as a mathematician, even if we do not know much of the biology, we should be able to do it. So what is it? We will see with this simple one example and then I will wind it up. Next. Okay, so the second problem is about a biological problem. Okay, I am sure all of you, many of you might have done a biology course in your 12th standard, or some of you have PCM, I don't know, but what the biology I am going to use is only the high school biology, 12th standard biology. Okay, so biological problem I am taking, and I want to construct a simple discrete model for this. So what is this problem about? I am interested in finding the RBC count. How many of you know what is RBC? Red blood cell. All of us are aware, right? So it is one of the contents present in our blood cells. WBC, RBC are two main important components of our blood that all of us are aware of. So my interest on this study is to identify in any circulatory systems the red blood cells are constantly being destroyed and replaced. So you might have seen in many of you, even if you watch closely the Horlicks advertisement in the TV, you will be able to see that one small poppings like red things will be rolling here and there, right? So they are the RBCs. So you will see that in our circulatory system, it keeps being refreshed. Some of them get spoiled, so they are thrown away, new cells are introduced. This constantly happens. Okay? So if it keeps going and something keeps coming out, is their model balanced, or do we have enough of them, or at a given day enough number will be there? So that is the study we want to just simply undertake that. Since these red blood cells carry oxygen throughout the body, their numbers must be maintained within a fixed range. There cannot be too many of them, there cannot be too low of them, right? So you know the medical consequences because of that. You may get leukemia and so many other diseases if the number is not up to the minimal. So now the present study, what is the present study? Assuming that the spleen, one of the organs in a circulatory system, if the spleen filters out and destroys a certain fraction of the cells daily, so the duty of the spleen is to pull out all the destroyed RBCs. Then there is another part within the circulatory system called the bone marrow that constantly feeds in refreshing new kind of RBCs. So the bone marrow produces a numbers proportional to the number lost on any given day. Again, I am making an assumption here in saying that proportional to what is being destroyed and removed by the spleen, the same amount is being pumped in by the red marrow. Only if that ratio of proportionality is balanced, then we will be able to get a realistic model. Okay, so my aim is to find out what would be the RBC count on any given end of the day. That is the idea. Okay, next. So, just to understand this biological process much better, a quick recap in 2-3 slides about what is this biological system we are considering. So, we need to know the basics of, or just an understanding of what is a circulatory system, what are RBC cells, what is spleen and its functions, RBC cycle in a circulatory system, and the low blood count and its pros and cons, consequences. So you can see this, you might have seen all your 12th standard books. It's a simple circulatory system what we have. So the main role of the circulatory system is to distribute blood throughout the body. Blood distribution is taken place by this. It passes nutrients, gases, hormones and blood cells to and from the cells of the body to fight diseases, stabilize the body temperature and feed to maintain the homeostatics. Next. Okay, these are the RBCs like the poppins you might have seen. Okay, about a quarter of the cells in the human body are red blood cells. Main function is to deliver oxygen to body parts. Approximately 2.4 million new red blood cells are produced per second. You can imagine this is the amount of blood cells produced per second. These cells circulate for about few days in the body before they are being recycled. Next. So you can see a simple small animation which is available here. You can see a small dot of red going from toe to head. That is the representative RBC taking oxygen to the entire part of the body. You can see here. So as it moves here, it squeezes depending upon the size of the capillary. It squeezes elongates, stretches, shrinks and all that. That is the reason it is getting destroyed also faster. Okay, so this you can see. Depending upon the size, it does both the part. It takes away oxygen, gives it to the body, takes the carbon dioxide and brings it out. So it does both the things. So depending upon the coloration, you can see the percentage of carbon dioxide and oxygen carried by them. Next. So this animation occurs at a real time of 20 seconds per cycle. It shows the RBC deforms as it enters the capillaries. It changes the color as it alternates between the oxygenation and the circulatory system. Next. So maintaining normal red blood cells is essential. You see that in any male blood cells, you are expected to have 4.7 to 6.1 million cells per microliter, whereas in female, you are expected to have 4.2 to 5. This is the normal average sizes. Next. So low blood count, if the RBC is low, what happens? The minimal number is not there. What is there? Consequences. If you look at it, it will cause anemia, leukemia, spleen disorder, immune disorder system. So many medical disorders will happen if you don't have the minimum enough count. That's why whenever you feel very fatigue or tired, you immediately go to the doctor, do your blood checkup. So to know whether your RBC count is right or not. Next. So as I said, spleen is a part in the circulatory system. You can see that it is somewhere in the corner. That small bean shaped, this thing is the peanut shaped is the spleen. So the role of the spleen is to remove the deceased RBCs. Next. So you can see the deceased RBC is there. It is mutilated, differently shaped. If you have a right circular poppin shaped one, it is the, now I think I should call it as not the poppins is now lost. Now what is the new name for it? Gems. Yes. Right? Gems is the most popular one. So if you have that regular shaped one, that is a good RBC. Anything which is of this disordered shape, they have to be immediately removed from the circulatory system. That is done by the spleen. Next. Okay, so now our objective is to find out the RBC count on any given nth day, knowing that if I want to do the studies, I should have a cohort of a group of people. Maybe I will fix 30 students. So I will call them, take their bloods, have the count. Okay. Then on the 10th day I will call them. On the 15th day, so over a month I will call them 5 sittings. I will have the measurement. So with that as my data, I am going like how we had in the earlier SARS case, we have a data. Here I have small data. I am going to do a simple mathematical model. Then I want to relate both of them to check whether my mathematical model is typically replicating the real data. Okay, so this data is available. If I go to JIPMER or Mahatma Gandhi Institute, they have lot of data to give me. Because when any patient they come, immediately they take the blood sample, they have all the measurements there. So this mathematical model will help it. In fact, why as a mathematician I started this analysis on biology was, my cousin she was doing MDS at JIPMER. So she is doing something with the blood, some taxology or some such thing. So she came up with this data. Then I said, this is how you can interpret. That is how this idea came up at all. Otherwise I wouldn't be interested in doing this biological type at all. So I said, for any nth, I will be able to give you a model. You give me a set of 5-6 models, 5-6 data from different groups of individuals. I will independently do a mathematical analysis and a modeling and a study. I will relate with all the different data you give me, a cohesive for all of them, one typical mathematical model I will be able to give. That was the challenge, and we were able to be successful up to 70%. The reason being, the study is not complete. That's how we think. Okay, so that was the idea with which we are doing this biological model. So what is the formulation here? Let the number of RBCs in the bloodstream on day n be denoted by R of n. So the number of RBC cells on an nth day is represented by R of n. Then the number of RBCs produced in the bone marrow. You know that every day there is going to be some cells removed by the spleen, some cells should be brought in by the bone marrow. So M of n represents the number of cells which is pumped in by the bone marrow. That is represented by M of n. Okay, we assume that the spleen filters out a fraction, say F. There I had the constant of proportionality of the disease is K. Here I am calling it as F. So if F represents the fraction of the filtered out RBCs by the spleen, then they say I also made a physical assumption depending upon the nature of the model that the number of cells sent out by the spleen is proportional to the one pumped in by the bone marrow. So to have that assumption here, the cells are being pumped into the bloodstream from the bone marrow. So with this assumptions and my parameters R of n and M of n, what is going to be my model? On the n plus 1 today, R of n plus 1, the number of, what is my R? Number of red blood cells on any n today. So on the n plus 1 today, how many it will be? Already the number present on the n today, that is Rn. Then why is it a minus that? What is F times Rn? Number of blood cells removed by the spleen is F of Rn. So I have to minus that from my Rn. Then what is a plus Mn? The numbers which is being pumped in by the bone marrow will be adding to that. So from the available RBCs on the nth day, remove the number removed by the spleen, add the number added by the bone marrow. That is my first equation. Is that making sense? Okay. What is my second one? Okay, so this is my typical mathematical or simple algebraic equations. But in terms of functions, I have on any n plus 1 today, the equation will always be like this. Already whatever is present, what was removed by the spleen, what was added by the bone marrow. That's all I have. Okay. So then, what is this equation? M of n plus 1. M of n plus 1 represents the number of blood cells added by the bone marrow. That will be proportional to the number removed by the spleen. So F into R of n is removed by the spleen. But how many bone marrow is adding is with a constant of proportionality and the new there. So I have one more constant of proportionality here. So I have these two equations R and M plus 1, M plus M plus 1. Next slide. So here I have a system of two simultaneous equations in Rn plus 1 and Mn plus 1. You know that Mn plus 1 is related to Rn. So I can go back and substitute it there, remove my n plus 1. So I can get one equation second order or two first order equation as a simultaneous system. So typically this is mathematically models as a system of simultaneous equations. But the study is not as simple as 2 pencil, 3 rubber cost this much, 5 pencil, 7 rubber cost this much. What is the price of pencil and rubber? It is not that. It is little more than that, because you need to understand the constant of proportionalities here which we have brought in. So that is going to be revealed. In the earlier case, this is spreading case, our myth of introducing the proportionality convents was removed by the error concept. We wanted to minimize the error. But here, the eigenvalue possessed by this matrix system is going to reveal the constant of proportionality. So you have to treat this as an eigenvalue problem, and also you see that on a given day I have the situation, on the nth day, maybe after 10 days, after 20 days what is going to happen. So that also is revealed by a eigenvalue solution, what is called as the diagonalization process, by which you will be able to sort this out. So when we model this way, analyzing the eigenvalue problem of this, the eigenvalue will tell you that this is going to be your proportionality constants, and the eigenvectors will tell you that this is how the rate of pumping in and going out of the red blood cells by the spleen and the bone marrow should take place. So that is going to reveal. I will skip the mathematical analysis of this because it's a bit more rigorous, but I wanted to give you the feeling that a simple problem can also be modeled in a very simple way by this, but the study analysis could be much more rigorous in terms of your linear algebra techniques. So I will just skip through most of them. So I realized that their eigenvalues are, of course this is 1 minus f and 1, f comma and 0 are the eigenvectors of the 2 by 2 eigenmatrix. Then you have to do a diagonalization process of this m to identify on any given nth day what happens. Next. So you will see their eigenvectors and eigenvalues form like this. Okay, consequences of eigenvalues. So you, as I told you, have to come back to the real life situation for interpretations. Why it has to be like this, why it cannot be like this. So if you look at the simple analysis, you will realize that. Next slide. If at least one of the eigenvalue is greater than 1 in magnitude, So you see that if the eigenvalue is greater than 1, then it mathematically tells me that I can keep on bringing in RBCs. But that is going to bust our circulatory system. It cannot happen. Maximal level is something 6.4 millions per microliter. Minimum is 5.2. So I cannot have too many, I cannot have too low. It has a specific range. So to attach with this range, I will be able to analyze and say that eigenvalue cannot be beyond this, and so I will be able to give a range. Within that only my eigenvalue can take place, the lambdas and the other things. Okay, so precisely it falls out as you have two proportionality constants, one F corresponding to spleen pulling out, and nu another proportionality constant by which bone marrow is pumping in. So you will realize that one of them exactly is 1 itself by the analysis. Next. So you see that the value of nu is identically 1. With a proper physical justification, we will be able to say the proportionality constant is exactly 1. Next. So you do some analysis next. Eigenvalues, we do some eigenvectors, you do the power n, I have to do on the nth day how we have to calculate. So this involves a little bit of linear algebra technique in diagonalizing your given matrix into its eigenvalues form. Okay, you do some eigenanalysis. Then you do the corresponding interpretations. Maybe I will even skip all this. Okay, now we come back. So this is another example of how a modeling can be achieved by a physical problem like this, which has a very practical applications in real life, which is also useful for a MD level student. Then, how good is a mathematical model? Mathematical model, if it realizes if it is closely related to the physical situation to which it is modeled. Okay, if it is robust, if it is consistent, that is, if you are able to do it repeatedly, we should be able to get the same kind of solutions. Okay, titration, if you do 1 today, you get some 10.4, tomorrow if you get 11.6, it's not a good one. The consistency has to be maintained on any day when you do this analysis, it should be the same. So that reflects on a good model. Does it suggest new ideas and concepts? If it is yes, it is a good model. Next, which aspects of the situation it models very clearly and which it doesn't? Like we saw in this disease predicates, first 10 days, last 10 days, it was reflecting very well, right? So, beginning and end, it was predicting correctly. So, we should be able to suitably adjust that. Can you solve analytically or numerically a given situation? The typical examples, what we have taken care, all were solvable analytically. We were able to give an exact mathematical equation as a solution. Many of them may not be solvable analytically at all. You need a numerical solution. A simple example is, if you are, what is the value of x for which x log x plus cos x is equal to 1? Will you be able to give me an x? You will never be able to give an x for which this is true. Only a numerical solution and approximate value is available for which this equation will be satisfied as 0.999999, any number of 9s you put, but it will never be 1. So you can get only a numerical value as a solution. You cannot get an exact x is equal to 3.2 satisfies this. You cannot say for certain kind of problem. So whether you are looking at analytically or numerically also comes into picture here. Then does it estimate the parameters very well, your model? Yes, it does. Can you validate this model? As I told you in the disease case, first 30 days I will take, I will check whether it is predicting my data available on the 50th day. That is revalidating your model. So the answers to all these questions decide about the strength and the quality of the mathematical model you have proposed for the given situation. So to conclude, we can make several conclusions. Next. So here you can see an interesting mathematical modeling of a growth of a plant. Supercomputers, availability of the computational power, you are able to build a tree or grow a tree on the blackboard itself, you see. But you don't realize the background of 8 months to 1 year data which was collected to show this 2 minutes animation here. So this shows the modeling of a plant, its growth and development. This is a computer simulation by which we can see the visualization of the maize plant. Next one. So So this is a young pine tree which you will be able to see only in the cold places like Kashmir, but you are able to see here as a numerical simulation. So all these two are basically done with a specific mathematical modeling considering various parameters here. So this shows the simulation of the pine tree. So how was this done? Oh dear, equation is not shown. Okay, it was implicitly mentioned. That should have been this gap equation should have come. Okay, doesn't matter. So you have your equation. Not to scare you, I think the equation was purposely suppressed. So what we see here, circle all the different parameters which is affecting the environment, light interception. You have what is called as the energy efficiency. You have what is called as the sinks function. Several parameters of this mathematical model, which was used to study the numerical simulation for the growth of the two plants what we have seen earlier. So in that way, mathematical modeling plays a very important role. It's a part and parcel of our studies. So one need to pay attention and importance in understanding the study of these subjects. So modeling, to conclude, takes a situation from the real world, removes it from the real world, converts it into a mathematical language, it solves and then replaces it back into the real world to see the mathematical solution. It should be a very, very basic software training. Next. Okay, where students want to be tomorrow? Immediate goals of the lives of students is whether they want to get a job or they want to go for higher studies, right? Then what will the students need to achieve to their goal? They have to clear the college level exam successfully and experience in the event management. In addition to that, if they have some knowledge of some software, basic software, it's an added advantage, right? Next. After your courses, after the successful completion of your final exams, if you have some leadership qualities, in addition to that, if you are able to have some basic training on certain softwares, it's an added advantage for you to get a job, right? So what if students can get some extra achievements in terms of learning certain software by increasing your knowledge, receive some more certificates and gain experience in project management. Okay, how do you get these extra achievements? From where do I get these extra achievements and when do I get this? All this can be answered by us. Of course, I am a representative from the IIT Bombay group. I am selected as a nodal officer for Pondicherry and its affiliate colleges, 82 colleges. So I am chosen as a person to spread this message to entire Pondicherry, Union Territory, all its colleges, so that they are able to take up this training. So we will teach you some new software and help you to find a job faster or get into higher studies smoothly. Okay? So how do we do that? You see that. So why is it necessary to learn this? Now you know that presently everything is technology oriented. So whatever you want to do, you want to make use of the computer to do it, right? So the spoken tutorials are basically an easy self-learning audio-video method by which basic knowledge of some certain software courses are imparted. And already videoed some certain lectures are available. So you are supposed to take up that as a part of the workshop, which through your head of the department or a coordinator from one of the faculties, that training will be given to you. Then at the end of the training, the entire course material also will be provided to you. You are supposed to read that course material thoroughly. After 2 weeks, you will be undergoing an online test conducted directly by the IIT Bombay, sitting in your own college lab, having internet facility. So it's a simple online exam of 45 minutes to 1 hour depending upon the software. Right at the end of your test, when you click the submit button that you have completed the test, you will get your result, whether you are passed or you have failed, whether you have got 52%, whether you have got 68%, whether you have got first among all the students. It will be revealed immediately on the screen. If you have got 50% and above in your test, then automatically a test certificate will be generated saying that so and so your name will already be there because you would have already registered for the course. You are with your name on such and such a day, trained by such and such faculty. You have undergone a basic train on that software. You will get it. It's already pre-signed certificate given by the IIT Bombay directly. This is for one particular software course I am talking. There are 20 such software courses available online as of now. Depending upon your speed of learning, your interest, your motivation, you will be able to generate at least 4 to 5 certificates in a year by taking up the training and doing it. And again, there are certain software suitable purely for chemistry, purely for mathematics, mainly for arts people and things like that. So you can choose among the softwares which is more suitable to you so that you can get trained on that. You will be able to get at least 4 or 5 certificates minimum. If you are not able to identify what kind of software courses will suit your field of specialization and this thing, IIT Bombay has a help with giving you a course mapping. If you are doing a BSc Mathematics, then IIT Bombay will suggest these are all the software courses which are useful to use. So among them, you get trained in any of them so that you can give the test and get the certificate. So there is also a parallel course mapping then. So what are the courses available? We will quickly go through. Next. Next. Okay, previous. Right. So name some software which are purely, now I don't want to do any studies, I want to go for only job. To decide that there are certain software courses exclusively for taking up jobs. Okay, I want to do higher studies, so which will be helpful for taking up the higher studies. You have certain classified software exclusively for higher studies. So we can classify them and give it here. So that's something called Python. I'm sure all of you might have heard about Python. It's another language as its own. So the knowledge of that will train you in a 3D animation, gaming industry, YouTube, NASA, CERN and Yahoo. If you have some keen interest and awareness and some kind of aptitude, you just take some time for 3 to 6 months to learn and in and out of Python. You may get a job in Yahoo which is 12 lakhs per annum as your industry. So such high potential job opportunities are there. Take one soft course, learn the basics from this workshop, and then you can even, there are advanced level courses also available by this free. Then if you are very confident of one particular thing also, you have a very good job potential and job opportunity. So Python is one such that. Now a lot of cartoon movies are very, very popular these days, right? So if you are able to create a model, just a 2 minutes movie, 2 minutes animation, send it across to people. Now even sending is free through WhatsApp and Facebook and Twitter and whatnot, right? We have to spend 400 rupees to apply for one postdoctoral fellowship just by the post. Those were the days. Now everything is online, everything is free. So it should be easier for you to communicate all over the globe, to show your ideas, your interest and your knowledge. So in that sense, it should be very easy. So learning Python is going to help you job in the animation industry. And Linux is a basic operating system. Now when you use a Windows, now they're all Microsoft based, you have to have a virus, antivirus software also parallelly. But if you use a Linux, you don't need antivirus at all. And it's a self-learning, it's freely available on the web. So you will be able to download it and use it. So Linux is one such. Next one is PHP and MySQL, all the data operations. Now that you have done this Aadhaar, everybody has Aadhaar card now. So you would have gone for so to every person who went for Aadhaar registration, they have collected lot of data from you, right? Your iris, your fingers, 10 fingers and date of birth, whatnot, so many other parameters. My voice is very loud. So when you see that there's a lot of data being collected from one particular individual, imagine our population, what is the kind of data we are dealing with here? Trillions and trillions of data, right? So how do we store all these data? How do we access that data? That's all done by your MySQL. It's a very basic data storing software. It's going to help you in getting a very good job somewhere in the data industry. So where the present trend is to analyze, you must have heard about big data analysis, Hadoop, all this. So it is going to be a very important role if you learn your MySQL through PHP. Then again LibreOffice, it's very close to your MS Office, you do your Word, docs file typing and all that. So it's very similar to that is LibreOffice. This is freely available. You don't have to pay money to get this software. Then LaTeX, again a publishing software. If you want to write any articles, you want to publish some work, only if you do it in LaTeX, many of the journals will accept in the research community. If you type it in Word, they don't accept it up. You do one page, again immediately this thing will shift. You keep on formatting only, the entire time will go to do it in Word. So that kind of hurdles are not there if you use the LaTeX software. Even for LaTeX software, basic training is available. Then Scilab is very similar to your Maple, Mathematica and MATLAB. It is a scientific laboratory. So to do any kind of computations, if you have a 10 system and 10 unknowns, a system of simultaneous equations, algebraically it's very tedious to solve, right? Even if you have a simple 4x4 matrix, either you want to find the inverse of the matrix or the eigenvalues of the matrix. We know those who have gone through this know the difficulty, right? We can never get the eigenvalues right first of all, leave alone eigenvectors. So for all that, mathematically how it is done, if you know the knowledge, then you can make use of the software to get the outputs or result in one line. So that's it. Scientifically, this is purely mainly meant for higher study software, or if you take a job in nationalized laboratories such as CSIR lab, DRDO lab, they will be asking you to use only this software to do your analysis. Scilab. Then C and C++, those who are not aware of the basics of computing at all, who didn't have the language courses, first BSc students especially, in the 11th and 12th, if you did not have a C and C++, this is an introductory programming courses. Then Java. Java is again most useful for all your design purposes. Then you have Blender, GIMP, there are several, so I'm just listing OpenFOAM, ASCII. Several softwares are available, all are coming under FOSS. What do you mean by FOSS? F-O-S-S, free and open sourceware. F-O-S-S, free and open source. So this is the most advantage of all these software. It is a free and open sourceware. Free, open source software. It comes under FOSS. For engineering education, we also see as FOSSI. Okay, only few of them I have listed with the importance of studying that. But if you go to the website of spokentutorial.org, everything is available. You can have a view of what is this about. You can thoroughly search and get it. So I have just scatteredly listed few of the software for which already the materials are available. You can download them with the help of your coordinator, and you can learn them and you can give a test on this if you are interested in getting trained in that software and get a certificate from IIT. So typically a spoken tutorial is an audio-visual movie to teach open source software. Already IIT Bombay had hired very intellectual peoples from several IITs. They have already prepared the course notes as well as the training material in terms of the PowerPoint. So that will be presented to you as a common in a workshop. Then individually it will be given to you. You can take it home if you have a system. You can put it on that or keep this earphone also and listen to the speeches and you can learn them. If some of you do not have a computer, you can print it out as this material, keep the study material and you can study also. Both ways it is possible and you absolutely don't need internet at all to do this. That is one of the advantageous thing. So make you learn the software from the scratch. Okay, unique way. Why is it unique? Depending upon your nature of studying habits. Somebody may be very slow learner, somebody is a very fast learner, right? So if you are determined, I want to get 4 certificates before I leave this course, then you finish it in 3 weeks, give the exam, finish, get the certificates, do the other one. Some of you are slow learners, you may take 2 months to finish a course, it's okay. Do 2 of them, do it perfectly. If some of you are like me, late night up to 2 o'clock, if you have a habit of sitting and learning, no problem. You have either the system with you as a PC or a study material with you. You can learn in a corner of a room at 2 o'clock, you can sit and read. Nobody is going to trouble you. So at your own pace, at your own speed, at your own time, you can learn. That is the advantage. Designed for girl students sitting in a remote place, trying to learn the software by herself at night. Okay, so this is all about spoken tutorial workshop. So typically in a renowned labs like IIT, how it is done, only 30 people are allowed to register. Everybody is made sit in front of a system. Already the software is loaded onto that system. They are supposed to quietly listen to them, keeping the earphones with them so that it doesn't disturb the others. Then parallelly you have practical sessions. They will open up another window on the same system. They will be practicing that. So that is the way the workshops are being done. Okay. And earlier days, this idea was started in 2010. In 2011, I conducted a workshop for my students, 60 students at Pondicherry University. So those days it was not very well developed as it is today. So if I had some doubt, students had some doubt, we used to keep the Skype on. So from IIT Bombay, there are always people be waiting. When I just click a button, they will come here, then I will be asking questions, they will be answering me as well as the audience. So it was a more of an audio-visual type with an interaction mode. Now it is all not there, everything is answered. Anything you want, just type it, you have a solution there. So you can directly get it. So it is all very, very well refined with lot of whatever the basic difficulties we had in 2011 and 12, all is rectified. Now it's a very pruned and standardized format. It is there, very easy to implement and get the training done, get the exams written, and the certificates are also instant. Those days we had to wait for 3 months. 1 month to get the results, 2 months to get the certificates. Now everything is made instant. So you can immediately realize the fruit of the test and the study at the end of the test. Next. Okay, so this is the project from the NMICET, National Mission on Education through ICT, Information and Communication Technology. NMEICT. This is spoken tutorial project envisaged, vision and practiced by the IIT Bombay. We are all only the representatives of them. So these are the set of softwares. If you want to have the basic skills, if you want to develop, if you want it for programming type, web development, different classes, different categories. So for all these materials are available, software training is available. At the successful completion, certificates are available. Course mapping, as I said, lucrative for jobs, for chemistry, for science courses, what are the different kinds of software which is useful. This is the next. So in different colleges, how the programs are being done. Some glimpse of that. So I have, as on today, I have successfully trained around 535 students under this software in and around Pondicherry affiliated colleges and the university. 535 students on 7 different softwares we have trained. He is the brainchild behind this project, Professor Kannan Mudgalia from IIT Bombay. So the process is, first of all, you students should be interested so that your teachers will take the motivation and start the training. You should register with IIT Bombay. Everyone should have a Gmail ID account, email account. That email account will be sent by your college coordinator to the IIT Bombay people. They will, within 1 day, generate a user ID and password for you individual students. Then you will have to log in with that to get the training material and getting trained and all that. So you should just give your Gmail account to your coordinator so that in turn is sent to the IIT Bombay to generate your registration. So please visit this website http://spokentutorial.org. It is not only for
It is indeed a pleasure to propose vote of thanks in this memorable occasion. First of all, I thank our chief guest, Dr. Rajeshwari Sheshadri, for having come over here. In spite of his busy schedule, we learned many ideas on mathematical modeling and admire how our modeling theory is highly related to our real life problem, and admire and from her lecture. Thank you, ma'am. I express my deep sense of gratitude to our principal, Dr. P. Jayaprakasam, for having initiated us to arrange the valuable lecture on a wonderful topic by an appropriate guest. I am thankful to the management president, E.R. Pon Balasubramaniam, for allowing us to do this remarkable event. It is a great honor to thank Dr. V. Savitri, Head of the Department of Mathematics, for his non-stopping help in the conduct of this special lecture. Thank you, Ananda.